Hi and Assalamualaikum. In this video, our group is going to present about operating system structure from chapter 2. Okay, so before I start, let me introduce myself. My name is Muhammad Abdurrahman and the other two group member is Ahmad Shafiq and Nick Khalis. Okay, so for the first operating system structure is simple structure. In this structure, many operating systems do not have well-defined structure. These systems start as small, simple, and limited system, and then grew beyond their original scope. So, for example of this system is MS-DOS and original Unix operating system. Okay, so let's look at the MS-DOS structure. This structure originally designed and implemented by a few people who had no idea that it would become so popular. The structure was written to provide the most functionality in the least space, so it was not carefully divided into modules. This lack of structure is evident in the fact that the interface and levels of functionality are not well separated. For example, application programs are able to access the basic I/O routines to write directly to the display and disk drive. So this will cause MS-DOS vulnerable to malicious program and will causing the entire system crash when user program fail. Okay, so next, original Unix operating system. Okay, so like MS-DOS, Unix initially was limited by hardware functionality. It consists of two separable parts, which is the kernel and the system programs. The kernel is further separated into a series of interface and device drivers, which have been added and expanded over the years as Unix was evolved. Okay, we can view the traditional Unix operating system as being layered to some extent. As you can see at the image here, everything below the system called interface and above the hardware is the kernel. The kernel here provide the file system, CPU scheduling, memory management, and other operating system functions through system call. Okay, this monolithic structure was difficult to implement and maintain. It had a distinct performance advantage. However, there is a very little overhead in the system call interface or in communication within the kernel. Okay, so that's it for my part. Other group member will continue this.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Shafiq. I would like to present for my presentation is about layer approach. So what is a layer approach? Layer approach is type of system structure in which the different services of the operating system are split into various layers. Each layer has a specific well-defined task to perform. It was created to improve the pre-existing structure like the monolithic structure Unix and the simple structure MS-DOS. For design analysis and example. So for design analysis, the whole operating system is separated into several layers. So the first layer is the outermost layer must be the user interface layer. The second one is the innermost layer must be the hardware layer. And the last one is a particular layer can access all the layer present below, but it cannot access the layer present above it. That is a layer n minus 1 can access all the layer from n minus 2 to 0, but it cannot access the nth layer. The example of the operating system that use this structure is Windows NT. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nick Muhammad Khalif bin Nazri. So for the last part, I would like to present about modules. Firstly, we go to the introduction. So the kernel has set of core components and links in additional services via modules, either at boot time or during runtime. This type of design is common in modern implementation of Unix, such as Solidus, Linux, and Mac OS X, as well as Windows. So the idea of the design. The idea of the design is for the kernel to provide core services while other services are implemented dynamically as the kernel is running. Next, linking service dynamically is preferable to adding new features directly to the kernel, which will require recompiling the kernel every time a change was made. Like that. Thus, for example, we might put CPU scheduling and memory management algorithms directly into the kernel and then add support for different file systems. And then the overall result resembles a layered system in that each kernel section has defined protected interface, but it is more flexible than a layered system because any module can call any other module. So the approach is also similar to the macrokernel approach in that the primary module has only core function and knowledge of how to load and communicate with other modules. But it is more efficient. Why? Because modules do not need to invoke message passing in order to communicate. Alright, so next, as we can see here, is a figure of the Soldering operating system structure. So this core storage kernel is organized around a kernel with 7 types of loadable kernel modules, as we can see, as you guys can see here, which is scheduling classes, file system, loadable system call, executable formats, stream modules, miscellaneous device, and bus drivers. So the advantage of Solaris is it gives better performance, have many good backup tools, can handle many users at a time. It is so fully virus protected and support the F5 system. But there is also a disadvantage of this Solaris, which is lack of good GUI. Solaris does have GUI support. This OS is not user friendly, and then it crashes, is insecure, buggy, and expensive. And then you can run Solaris for free, but you can't get updates for free. So that's all from me and from my teammates. Thank you. And Assalamualaikum warahmatullahi wabarakatuh.